Line diagrams. You are by now so familiar with molecular formula, structural formula, and condensed formula that you're ready for the next type of notation. It's even more compact than the condensed version. Let's consider propane. You know from your observation of models that it's really a zigzag structure like this model shows. Here's another longer one, pentane. The zigzagging of lightning on the title page is supposed to reflect this idea. This shows how we would show propane. What could be simpler yet possibly confusing? It's understood that at the ends there's a carbon with 3 hydrogens making methyl groups. At any point or corner there's carbon with 2 hydrogens. Here is pentane. Here is pentane with a methyl group, and here it is without the terminal carbons, and this is the version you need to get used to. If we number the carbons and note the methyl group on carbon 3, we get 3-methylpentane. Let's look at this one with terminal carbons and without them. Which end do we start numbering from? Let's decide by looking for the first point of difference. These end carbons are both methyl groups. I could also have started with these methyls. Either way is okay. No difference here. The next carbons both have the same connection to a methyl group. Again, no difference. The next carbons do show the first point of difference. This carbon is connected to 2 hydrogens and 2 carbons, but this carbon is connected to 1 hydrogen and 3 carbons. That gives it a higher priority, as it were, so we start counting from the right side. Another way to look at this is that this carbon has a methyl side chain, while carbon 4 has none. So we have methyl groups on carbons 2,3,5 and obtain the name 2,3,5-trimethylhexane. Now, just some practice for you to master this system. Here are 3 alkanes. The first example with chlorines may look uncomfortable. Here it is showing the connections clearly. I'll give you 3 alkenes after you've tried these 3 first. Here's the first answer. The second answer. For the third one, I'll first deal with the numbering direction. Should we start from here or above? Either branch is okay. Or from this end? Again, either branch is okay. Where is the first point of difference? These ends are the same. The next carbons are different, that is, show a first point of difference. The left carbon has a methyl side chain, while the carbon on the right has none. So numbering starts from the left. Notice carbons 2 and 3 have methyl groups, and carbon 5 has an ethyl group. Suppose we name it in this order. We get 2,3-dimethyl-5-ethylheptane. What do you notice about this name that is incorrect? It's not in alphabetical order. Ethyl comes before methyl. It's important to note that prefixes do not count for alphabetizing. You may have thought the D in di would make dimethyl come before ethyl. Since prefixes are ignored for this, the correct name is 5-ethyl-2,3-dimethylheptane. Now try these alkenes. Here are the answers. Finally, some practice with alkynes. So this looks really strange. It'll help if I show the condensed formula here. This shows exactly where those carbons are at the end of those lines. So this is acetylene or ethine. Let's look at this one. Again, where are those carbons? It'll help to show the condensed formula. Here again, that's where those carbons are. And then the other carbons at the end. Now it's more easily recognized as 2-butyne. Now you can try this one. To help, here's the condensed formula. See how they match up. So you should be able to name this as 1 pentyne. How about this one? Do you think you can name it before I show the condensed formula? Here's the condensed formula. Now you should recognize this as 2 pentyne. Here's the last two. You can try the one on the left. Here is the condensed formula. See how it fits neatly over the line diagram. All right, do you see that this is 3,4-dimethyl 1-hexyne? I'll leave this one to you. I don't have a condensed formula for it. You should be able to see that this is 4,4-dibromo-2-hexyne or 4,4-dibromo-hex-2-yne. The hex-2-yne method can be applied to all the others on this page, except for ethyne. And that's the end of this video on line diagrams.